Hi guys. This video we're going to be talking about the OptyFi tech stack. The OptyFi tech stack essentially was built from the ground up to systematically generate yield on any token in DeFi. It's important to note the word systematic. We didn't want to kind of do it on an ad hoc basis, one strategy at a time. We sort of wanted the view of the entire landscape. And identify the best strategy of the moment and be able to execute that. So there are two different videos. We're going to divide it up. If you look at the tech stack, the OptyFi tech stack divides up neatly into two high-level areas. The first one is we have to have the ability to run any strategy in DeFi. And that's what we're going to talk about in this video. In the next video, we're going to talk about identifying the best strategy to run. So let's get started. The first half of the OptyFi tech stack deals in being able to run any strategy in DeFi. And these are sort of the three components. Strategy composition. How do we actually think of strategies and how do we compose them dynamically so that we can build hundreds and even thousands of different strategies? Execution. How can we get one set of smart contracts to be able to run any of these many strategies all on chain, and how this relates to risk, etc., risk enforcement. And then thirdly, how does this expand? How can we continually expand this to other protocols, other pools, chains, etc.? So that's sort of a roadmap for this video. So let's get started. Let's talk about strategy composition. But before we do that, the end goal that we wanted to achieve is basically summed up in this picture. We essentially wanted a user to be able to deposit their assets into a vault, an OptyFi vault, and then over time, the OptyFi vault will keep placing the assets into the most optimal strategy, optimal by risk, returns, incorporating costs, gas costs, transaction costs, etc. In other words, do all the heavy lifting so the user doesn't have to. That was a goal. And that seems like a simple goal, but to achieve that, there's a lot of complexity involved. And that's sort of what I'm going to try at a high level to kind of give you a very big high level overview on what that tech actually does. So let's start with actually how we compose. Like I said, let's start with strategy composition. So what do I mean when I say strategy composition? Well, how do we think about strategies? Sorry, just give me one moment, please. I'm trying this this way for the first time. Okay, so if we look at the most fundamental aspect of the fundamental element of DeFi, they are tokens and liquidity pools. So how we think of a strategy, it's not the way strategy is used. Typically, we kind of use we think of it as a sequence of steps. So assume you had a token one, and you can deposit that into a pool. Let's call that pool one. Usually you get another token, a pool token out of this transaction. So let's call that, assume that's token two. Now, if you can identify another pool in DeFi, which can take token two as an input or an underlying token, then you have a two-step strategy, etc. Now, what happens when you do this across DeFi is you get basically a graph. So that's what we call a graph of strategies. Essentially, what it looks like is this. Okay, so this is a subset of the pools we right now have integrated into the OptyFi protocol. But the idea is that each node on this represents a token or a pool. And the starting node is a token. And basically what you can do is, let's say you're starting at USDT. From USDT, you have several strategies available to you, several steps. You can go into Aave USDT. You can go into you know three curve, which is a curve pool, and from curve you have other pools you can go into. Another way to look at it is essentially this diagram. This is from a vault perspective. So let's say we want a USDT vault. All we need to do is really just tell our system that, hey, what are all the possible strategies for USDT, and just run it, and there you go. So now we have starting at USDT. You can go into compound, CUSDT. You can go into Aave USDT. You can go into curves, three curve pool, or you can actually go into. There's actually two. There's an Aave three curve pool and a three curve pool, and then you can actually go into convex, etc., etc. Right. But for us, we don't have to say, okay, now we want to launch a token. What are the strategies? We have sort of this graph, and we can just plug in. Let's say I want to see what are the DAI strategies. So D A. And these are all the possible DAI strategies. Okay, so that's what we mean by systematic approach. And then, if you think about it, what really each edge. So the systematic approach gives you a couple of things, right? Firstly, each edge has a return or an APY. Also, we can start looking at risk from a perspective of different metrics. For example, the volatility of the pool, or the how reliable the protocol is, et cetera, et cetera. So you can now say, what are all the safest DAI strategies? In fact, that's how we do it. We basically have a risk framework that goes something like this. The lowest level of risk is our save vaults. Then we have earn, and then we have invest. And sort of as the risk is going up, obviously your yield is going up. So save vaults are looking at no loss. For example, lossless staking, lending on Aave and Compound. Earn vaults, we allow multi-asset pools, so we allow a little bit of impermanent loss, but that is only for pegged assets. So it's USDT, USDC, but not volatile pairs. And then invest strategies, we actually allow volatility. So what we can essentially do is we can say, we can look at, for example, this graph and say, okay, just show me the save strategies, right? And it's going to remove some of the edges, and then only a few are left. So that's what we mean by systematic approach to yield. We are identifying systematically yields. We're identifying systematically risk. If we sort of use that approach, then that opens up like a universe of strategy. So what we like to say is the DeFi, the universe of DeFi. Sorry, the structure of DeFi defines the universe of strategies available to us. So that is the strategy composition layer. And now the next challenge was how do you execute any of these strategies? So just to kind of point out that the way other protocols do it is that they have sort of one-off. So let's see. This is Yearn, USDC. This is Yearn. So this is the USDC vault, and these are the strategies that are available. Not all of them are operational. They're like sort of one-off strategies. Some of them have been retired, I guess. But each strategy is essentially a smart contract. So this is a strategy that's a smart contract. You can see it here, et cetera, et cetera. However, for us, instead, we have developed sort of like a high-level programming language. Sorry. So what we've done is, for us, a strategy is a one-liner. Okay, because of the way our contracts are developed. If you look at this on our webpage, you can see we have strategies here. So we develop sort of high level language, high level command line language, not command line, but we can send our smart contracts this line, for example, WETH, deposit into Aave, borrow USDC from Aave, deposit into Curve 3 Curve pool, and then further deposit that into Curve GUSD pool. Okay, so that one liner is an entire contract because of the way we basically developed our smart contracts. This allows us then, obviously that once we see, hey, essentially instead of having to code, dozens and dozens and dozens and dozens of strategies, we have one set of smart contracts and that can run any strategy. Basically, the way it works is that we have an architecture, and now we're getting to the next point, I guess. The expansion essentially is every time we want to add strategies, we don't actually literally add a single strategy, we add a protocol. So let's say we were at protocol XYZ, all its pools would appear here, and then all of its pools would appear, and the connections would be obvious because of the relationship that I'd shown you. In fact, let me show you also how the architecture looks as well. Just one second. So the way our architecture looks is that we have vaults on this side. Oops. And like I said, we can spin up a vault and we automatically have the strategies the vault can run. It's not like we have to code specific strategies for each vault. So we have vault, let's say DAI, USDC, ETH, etc., etc. And then we have our sort of core contracts. So our core contracts are our strategy manager, risk manager, and this is all on chain. So strategy manager's job is to kind of structure a strategy and run it, and I'll get to how in a minute. Risk manager puts last minute risk constraints. So one of the cool things is if we can essentially each pool on chain can be assigned a risk rating, then real time those ratings can change. So let's say we have an oracle that says the risk ratings are XYZ, or we in the future there's an S&P of DeFi, and that's providing risk ratings. So we can actually set the pool ratings to be real time, checked by the risk manager before any. So if a vault is trying to run, it's a safe vault, a low risk vault, is trying to run a strategy that's just changed from a low risk strategy to a high risk strategy, it will be blocked. So that's how risk is enforced on chain. So yeah, in this architecture, you have your risk manager, you have your strategy manager, and then you have your sort of strategy provider. Pardon my writing, which essentially is what we call our optimization engine. So this is recommending strategies. So for each vault, this is like an oracle. That's our own like sort of proprietary oracle that says, hey, for ETH, this is the best strategy of the moment for the vault. So if it's safe vault, the low risk strategy of the moment. And then what the vault does is it says, okay, I need to run this strategy, but the vault itself doesn't know how to run it, so it calls strategy manager. So it pulls what the best strategy is and calls the strategy manager execute the strategy. Now, strategy manager can say, okay, there's 2 steps, 3 steps, borrow it, can kind of structure it, but it doesn't know how to deal with different protocols. And that's where the expandability layer comes in, right? This is kind of the core contracts, and this is the expandability layer. And just to give you an idea, we have about 17,000 lines of Solidity code. About more than half of that is in the expandability layer. So here's where you have an adapter. We call them adapters for Aave, for Compound, for Curve, and for Sushi. So you can just imagine that just adding in one adapter, we basically get like lots and lots of pools, which means we get lots and lots of strategies. So you sort of have this optimization engine off chain, which is so we have these adapters which know how to deposit in Aave, they know how to withdraw from Aave, et cetera, and they basically send the strategy manager these commands, which sends it to Vault, and then Vault runs it. But the idea is we keep expanding these, and our protocol keeps growing and growing and growing in scope, while the optimization engine is kind of monitoring these pools for volatility, for APYs, et cetera, and recommending the best strategy to be in. So um, essentially, if we look, so we've actually done a lot of work in expansion, like I mentioned. And if we look at this is our internal team documentation, we actually came up over time with a quite a robust process for adding new protocols integrations, right? So we've kind of defined it here. We do a protocol analysis followed by technical research. We usually define an MVP, so a minimum number of pools. We learned the hard way rather than trying to get all edge cases first time around, just the most important pools. And we also, for each adapter we add, we have to add a data feed, right? Because our optimization engine, recall our optimization engine here, actually needs data on Aave, on compound, to be able to recommend the strategy. And then the adapter is the one telling us how to actually run it. So that's the adapter and optimization engine's data feed. So adapter data feeds go hand in hand. So just to give you guys an idea, we use Subgraph right now for our data feeds, but we're planning to use something else in the future. These are like adapters we've built, deployed. We have these built. We're not deploying them, or we might in the future for various reasons. These are Ethereum subgraphs. We have millions of rows of, I think it's millions of events definitely that we have in our data feeds, but hundreds and hundreds of pools that we monitor. Polygon are also actually this needs to be. We've deployed a lot of these, et cetera, et cetera. We have Avalanche adapters that are in integration testing and ready to go, et cetera, et cetera. So we've come up with quite a systematic way of keeping expanding this protocol. So then again, to summarize, all I've shown you today is this part of our tech stack, which the objective was to be able to run any DeFi strategy, pardon this, and keep expanding in a modular way. And in the next video, I'm going to cover how our optimization engine actually identifies the best strategy. So I guess see you in the next video.